Okay, today we are going to answer these questions. How far have humans been able to drill into the earth? What scientific principle causes the different layers of the earth? Which two elements are found in the inner core? And are they solid or liquid? We're going to click on this little YouTube video here, which I've already done, and we're going to watch it. And this is where you're going to get your answers from.
Hey, I'm just making a planet. Well, this is how planets like Earth get their structure anyway, because of different layers of density. Even today, with all of our modern technology, we've only been able to drill about a third of the way through Earth's crust. So, how do we really know if it's solid, liquid, hollow? Luckily, Earth has this tendency to violently shake and occasionally burp up some of its insides. And that's taught us a lot about our planet's guts without having to go down there. We're used to seeing density at work. That's the same reason that the atmosphere, the least dense part of our planet, is on the outside. And the crust, the second least dense part of the Earth, is beneath our feet. Because I'm less dense than the dirt, I don't sink into the ground. And even though there's about 1 ton of atmosphere above my head, it's not dense enough to send me floating. The main layers of the Earth are organized in the same way. Depending on whether they're divided up by how they squish around or what they're made of, geologists give different names to the different layers of the Earth. So that's how it is now. But to really understand why the Earth is organized the way it is, we need to go back to before our planet even existed. In the very young universe, hydrogen and helium were pretty much the only elements around. They condensed into stars, began the process of nuclear fusion, and eventually died, spitting heavier elements from carbon and oxygen to things like nickel and gold back out into the universe. One of those heavy elements, iron, is the most stable element produced outside of a supernova, and the early universe produced a lot of iron. That'll be important in a second. Fresh hydrogen and helium went on to form new stars like our sun, and the heavier elements collided to form the dust and debris that would become our solar system's planets, and moons, asteroids, and everything else. High temperatures in the early inner solar system meant that light volatile elements could only condense further out, which is why the four inner planets of our solar system are dense and rocky, while outer gas giants like Saturn could hypothetically float in a really big swimming pool. After proto-Earth grew larger, radioactivity, gravity, and violent boom booms melted that messy mixture of rocks and minerals, and this is where things started to get organized. Just like that tower of density, the heaviest materials like iron and nickel worked their way to the core. The lighter materials like aluminum and silicon stayed near the surface. The inner core experiences pressures more than 3 million times what we do on Earth's surface, which means that despite being as hot as the surface of the sun, the iron in our planet's inner sphere is likely solid and not liquid. The outer core is most likely liquid because it's hot, but not under as much pressure as the inner core. We know that's the case because of earthquakes up here on the surface. As certain kinds of seismic waves travel through the Earth, the liquid outer core either refracts them or blocks them altogether. And that creates seismic shadows on the opposite side of the planet. If you want to use pressure to melt metal at home, just stack up 16 million pennies. The one on the bottom should liquefy in no time. Mercury is so close to the sun that its atmosphere has long since blown away. But luckily for you and me, our liquid metal outer core lets us have an atmosphere. Deep metallic convection currents create a magnetic field that shields Earth from the solar wind. Otherwise, we'd be pounded with deadly radiation. Our atmosphere would be blown away, and Earth really wouldn't be a very lifey place. Over time, Earth continues to cool, so more and more of its liquid outer core is turning solid, and we're shrinking little by little. Every earthquake that we feel is Earth taking one step closer to cooling off and becoming a real third rock from the sun. So there you have it. Like Carl Sagan said, we are star stuff who has taken its density into its own hands. Its density.
Density.
Stay curious. People,
Okay, so after watching this video, you're going to take and you're going to answer these questions right here into these. Okay? The next slide. Below the ground you stand on, there are thousands of miles of earth, which consists of different materials, including rock, soil, rivers of water, volcanic lava, solid and solid iron, among other materials. There are also many layers of earth. These layers consist of crust, the mantle, and the core, inner and outer. Miners are people who dig holes for a living and use specialized equipment to dig deep into the earth. The crust is the earth's outer layer, what we stand on, and is made up of oceanic and continental crust. The crust is the thinnest layer of all the layers. Beneath the earth's crust is the mantle. The upper layer of the mantle is the semi-molten and can flow, which allows the crustule plates to move. The heat causing the rocks to rise and fall is called convection. The mantle is also the largest layer. The Earth's core is the size of the planet Pluto. The core of the sun is the center of the Earth and is divided into two parts, the inner core and the outer core. The core is very hot, measuring about 10,800 degrees Fahrenheit. The outer core is the molten state and found between the inner core and the mantle. The inner core is a solid ball of metal made up of nickel and iron. So right here you can choose to draw it, or you can tell me what it is. What is the inner core? What is the outer core? And what is the crust? How do scientists know how hot Earth's core is? They can't see it. They can't dig down deep enough to use a thermometer to measure the temperature. Despite the fact it's right under our feet, Earth's core is inaccessible. Scientists have produced ways to study Earth's layers. To learn what lies beneath the Earth's surface, geologists have used seismic waves. Earthquakes and other tectonic plate movements create seismic waves. By measuring the seismic waves, scientists can learn a lot about the composition of the Earth's layers. The layers are made up of different materials that vary in thickness. Researchers can analyze how seismic waves bounce off the boundaries between various layers and determine the composition. You have convection layers and then seismic layers. I would like you to tell me what each one of these are. On this slide right here, you're going to answer these questions. How do scientists know how hot the core is? A, thermometers. B, seismic waves. C, oil wells. D, measure electromagnetic spectrum. 2, what is the best title for this passage? How scientists explore the inside of Earth. Details about each of the Earth's layers. Tectonic plate mania, or the rock cycle. 3, the Earth's core is about the size of A, Saturn. B, Pluto. C, the United States. Or D, New York City. We're going to skip that particular slide. Part 2. Layer 1 is called Earth's layer. It is the thinnest layer and made mostly of granite and basalt. If you think that the outer layer of an apple, the Earth's crust would be compared to that. Which do you think this the densest layer or the least dense layer? Why? So is the crust the densest or the least densest? Tell me right here what your answer is and explain why you chose that answer. Layer 2 is called the Earth's mantle. It's the thickest layer and made mostly of magma, which is lava within the Earth. There are convection currents in the mantle that cause tectonic plates to move as the heat flows. Why do you think we know very little about the mantle? Put your answer here. Part 4. Layer 3 is called the Earth's outer core. It is made of mostly liquid iron and nickel. Scientists believe the magnetic field properties of the Earth are caused by this layer of the Earth. Why do you think the outer core is liquid and the inner core is solid? Put your answer right here. Explore it 5. Layer 4 is called the Earth's inner core. It is made up mostly of solid iron and nickel. It is the Earth's densest layer. Even though it is as hot as the surface as the sun, it is solid. How do you think the scientists are able to study the center of the Earth? Put your answer here. Now we're going to click on the research it. And as we read through, I want you to think and answer these questions. What did geologists study in the early 1900s to learn more about the Earth's layers? Click on the crust. What is the most characteristics of the Earth's crust? What are the 2 regions of the mantle? What region of the mantle is denser? What is unique about the outer core? What 2 elements of the outer core is mostly made of? The Earth. Think it's solid as a rock. Our planet might seem fixed and rigid, but a closer look reveals that it is constantly shifting under our feet. Delve into the Earth's interior and learn about its tectonic plates and their movements, and discover how mountains, volcanoes, and earthquakes are formed. So we're going to click on the crust. The crust is hard and rigid. It's the Earth's outermost and thinnest layer, only a few miles thick under the oceans and averaging 20 miles thick under the continents. The mantle is subdivided into 2 regions, upper and lower. This dense layer, made of hot semi-solid rock, is located directly beneath the crust and is about 1,800 miles thick. So right here you have the mantle, then you have the ionosphere. The ionosphere is the plates of the lithosphere that move or float on this hot, malleable, semi-liquid zone in the Earth's upper mantle directly underneath the lithosphere. The lithosphere is made up of the crust and a tiny bit of the upper mantle. This layer is divided into several constantly, very slowly moving plates of solid rock that hold the continents and the ocean. The inner core is an extremely hot solid sphere of mostly iron and nickel at the center of the Earth. It is 3,200 to 3,960 miles below the surface and about 750 miles in diameter. Outer core. The outer core is the only liquid layer of the Earth. A sea of mostly iron and nickel is roughly 1,800 to 3,200 miles below the surface and about 1,400 miles thick. Back to the mantle here. The mantle, once again, is subdivided into 2 regions, upper and lower region. This dense layer is made of hot semi-solid rock and is located directly below the crust and is about 1,800 miles thick. So after listening to those facts, you're going to answer these questions right here. Right here, you're going to take and you're going to put the outermost layer first, all the way to the innermost layer. Then you're going to match where these go. Do they go with the mantle? Do they go with the outer core, Earth's crust, or inner core? Illustrate it. You're going to get a paper and you're going to draw the Earth, and then you're going to label the layers of the Earth on the inside. You don't have to draw the continents or anything, but you're going to insert it here on slide 14. By doing that, you're going to follow these instructions. You're going to draw on your paper and take a picture and upload that picture onto this device. Or if you feel like it, you can open Google Draw, Paint, or any other graphics app and draw your image, then take a screenshot or picture of your image. For either option, you're going to click on the plus button at the top and it's going to click down and you're going to insert your picture right here. Right here, you're going to answer the questions. Why does the Earth have different layers? Question 2, list the layers of the Earth and provide a short description of each layer, starting with the center of the Earth. How is density related to the layers of the Earth? Okay. Put the layers of the Earth in order from the densest to the least dense. A, B, C, or D. Crust, mantle, inner core, outer core. Inner core, mantle, outer core, crust. Crust, mantle, outer core, inner core. Inner core, outer core, mantle, crust. Which layer plays the greatest role in the movement of tectonic plates? A, crust, B, mantle, C, outer core, D, inner core. Which two elements are mainly found in the inner and outer core? You have iron and nickel, iron and silicon. Nickel and silicon are nickel and carbon. You're going to use the vocabulary words that were bolded in the read it section for this. So we're going to scroll back up here and I'll call out our bolded section here. So our vocabulary is crust, mantle, convection, outer core, inner core, seismic waves, granite and basalt, magma, convection currents, that is all of our vocabulary words that we have. You're going to choose those words and decide where they fit best into this paragraph that says the interior of the Earth has different layers. At the center of the solid ball of nickel and iron is called the blank. Just outside the layer of Earth is a layer of molten state that we call the blank. Moving towards the outermost layer of Earth, or the blank, we find the mantle is the semi-molten. The hot material rises, cools, and then sinks in a cylindrical process called blank. Then the slabs of the rock that lie on the mantle interact with other blank and are produced by earthquakes and other tectonic movements. These can be destructive to the surrounding environment. You will click on your numbers here and put your answers in. All right, moving on, we're going to do challenge it. We're going to do demonstrate, brochure, crossword, and write. Okay, you're going to create your own diagram, artwork, or model of the layers of Earth. You're going to be as creative as you want to show the layers and their relative thickness. So you can do this several ways. You can draw on a piece of paper, you can take a picture and upload it that way, or you can draw on Google Draw, Paint, or any other graphics app that you might want to use. And you're going to take a screenshot. Then you can take and insert it through the plus button that's up here in your iPad, and then enter in your pictures and you can insert it that way. Then you're going to make a travel brochure. You're going to imagine a trip to the center of the Earth using the internet or even this research station lab for research. You're going to create a travel brochure that includes the layers of their relative thickness and their compositions and anything else you think is important. Once you've created it, you can do it on paper or you can choose to do a brochure on Google Docs. and you can link your doc or take a screenshot of it and put it in here. And then on this one, you're going to create a crossword puzzle using at least 10 of the vocabulary words that you've learned from this station lab. And you're going to make sure that there's a key for us to solve. Okay. And you can go ahead, and if you use this website right here, I will make sure that I link it into Canvas for you. You're going to create it, and then you're going to save it, and then once you've saved it, you're going to insert a screenshot of it, and then once again you're going to hit the plus button and upload it. You're going to write a story. You're going to imagine that you're a piece of rock. Write a story about how this rock might have traveled through the layers of Earth and describe what the rock would experience in each layer. You should use at least 5 complete sentences, okay? You can write it in here. You can open a Google Doc, and you can screenshot it and put it in here, but as long as it makes it into this box. If you have any questions or concerns, you can email me or call me or text me.